Hello and welcome to the wolfSSL live webinar, Getting Started with wolfSSH in 2024, presented by wolfSSL software developer Jacob. My name is Shizuka and I'll be moderating the webinar. All attendees will be in listen-only mode. If you have a question, please use the Q&A box. We will host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite you to follow us on Twitter at wolfSSL as well as other socials. Also, feel free to email us if you have any additional questions. And now I would like to give a brief company overview before we move to the technical presentation. Today, wolfSSL secure over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of over 50 dedicated employees, most of which are engineers. This progress is of course supported by our strong partner network that we are proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfClip with DO178 support, HIP certification, and a HIPS-ready offering, MQTT up to the V5 specification, SSHD2, TPM 2.0, a secure bootloader known as wolfboot, as well as a Java wrapper and a JSSC support, and a commercial support for Coral. All of these offerings are accompanied by through maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I would like to turn it over to Jacob to talk about getting started with wolfSSH.
Thanks, Shizuka. Yeah, so for this webinar, I'll be going over, as Shizuka mentioned, getting started with wolfSSH. Start off a little bit with the SSH protocol overview. Specifications supported by wolfSSH, a bit of the wolfSSH architecture. This will be something like the directory structure and how wolfSSH is set up. Configuration and build process and examples and applications before we get to the end with a Q&A session. So a little bit about the SSH protocol itself. It was invented back in 1995 by Tatu. For the protocol overview, it's a public-private key use for authentication. It can also be password authentication. Provides a secure tunnel between two endpoints. Typically, it's used to replace telnet. So if you have like a old system with a shell connection and it's just a basic like telnet connection, SSH was initially developed to be a replacement for that, to provide a secure connection instead of just having the unsecure telnet connection. Some of the other protocols that sit on top of wolfSSH is SCP and SFTP. Those are protocols that get used after the SSH connection has already been established. Some of the other common use cases for SSH is the multiple data channels between endpoints. As mentioned before, it's used for like a shell login. That's the typical use case that people think of when they think of SSH. It can also be used for tunneling applications, being able to run applications remotely, and even viewing the GUI of an application if you're looking at like X11 tunneling. It also supports port forwarding, FTP work-alike, and copying files, similar to the CP command. For the handshake, when SSH is first being initiated, the SSH client sends out basically a packet that it wants to initiate the connection. This includes the SSH version, and the server responds back with a banner and SSH version. This banner is a string for the most part, and it can be anything that the SSH server wants to send back. Typically what it's going to be is like the SSH implementation and version number. For example, like wolfSSH 1.4.15 sent back in our banner message. Then the key exchange in it is sent and then responded back to by the server. And this is setting up the algorithms that are going to be used and the key types, RSA, UCC key types. Then new keys. So this is the exchange of keys being sent back and forth to be used for encryption. After that, all of the messages sent back and forth are encrypted. The client then sends out its user auth request. Server responds back with the authentication methods that it supports. This is going to be authentication methods like public key or a password authentication, sometimes even none for no authentication. The client sends us credentials and then gets the results of the authentication back from the server. And after that, the SSH handshake has been completed and application data is sent back and forth. And at that point, it could be like the SCP or SFTP on top of this already established SSH handshake. So what is wolfSSH? wolfSSH is an implementation of that protocol. It's a lightweight and embeddable library written in C. We've recently added a couple of applications to it as well. It's an implementation of the SSH2 protocol stack. There's SSH version 1 and SSH version 2. Rarely you'll see version 1 out there. The SSH version 2 is the most commonly used one. It's also got a minimum footprint size of 33 kilobytes, so it's very lightweight, lends itself well to embedded use cases and resource constrained devices. It's designed to use wolfcrypt for the cryptography primitives, which is great because then you can make use of like the FIPS 140-2 or 140-3 certification. It's not tied to any specific threading model, has the password and public key authentication, and we also have the X509 authentication in wolfSSH. So our C software library, it's been tested for interoperability with other implementations of SSH, where it's just an implementation of the protocol. It can communicate with other implementations of that same protocol. So we've tested interoperability with OpenSSH, PuTTY, FreeSSHD, Bitvice, and FileZilla. A little bit about the history of wolfSSH. The original use case was to be a server to replace a serial port or telnet socket on an embedded device. It was used for like logging and configuration. That was back in 2014 that the first commit was made to our GitHub repository for wolfSSH. Then in 2017, it expanded to provide client support. At that time, it was basic, like a basic example client was added in. Then client support as far as in the library as well. So we had added like the wolfSSH_connect API so that application could use the wolfSSH library in a client setup. And after that, in 2018, 2017, we added new ciphers, added SFTP and SCP in 2018. And these are the two protocols that run after the SSH handshake has already been established. And we added a TCP/IP port forwarding also in 2018. So it was a pretty big year for wolfSSH in 2018. It also saw the addition of pseudo terminal support at that time. And the pseudo terminal support is when people think of SSH, it's often what they're thinking of. That's like logging in and you get your bash shell kind of set up so that you can run just like you're running a terminal on the remote system. Then in 2020, an SSH agent support was added. 2022 saw the addition of X509 certificate support, and 2022 also saw the addition of SSH daemon support. Then recently, just last year, 2023, we saw post-quantum support. And there was actually some interoperability done with other servers. So we have post-quantum support and interoperability testing. Then a wolfSSH client application was also added last year. And this is more of like instead of just being able to use the wolfSSH library with calling to client APIs, it's an actual application or executable that can be installed when the wolfSSH library is built and installed. So why would someone use wolfSSH over the other implementations that I mentioned earlier? Some of the reasons for its use is it targets portability and also resource-constrained embedded devices. We've done quite a few projects on edge devices that really don't have much memory available. It makes use of wolfcrypt for crypto operations. As mentioned before, it can be FIPS certified and also gets the best tested cryptography plugged in for all of its crypto operations. All of the original authors are still maintaining the code base and available for support and assistance, which makes it nice if any issues do arise. It has a simple API set. Some of the algorithms and hardware acceleration supported with wolfSSH, as mentioned, was the post-quantum crypto ECC with Kyber. We have multiple hashing functions available since it goes down to wolfcrypt. Supports AES for the block and stream ciphers. That's CBC, CTR, and GCM mode. And then it also supports RSA and ECC. ECC supports multiple curve sizes. So it's the NIST P256, 384, and 521. For client authentication support, it's RSA ECC key. It supports password authentication, X509 certificate authentication, and I guess I also didn't list here, but it supports none if you were to select no authentication. For hardware acceleration, where it's leveraging wolfcrypt, it gets access to all of the hardware acceleration that's available there. So some of the ones to call out is the Intel AES-NI and AVX, things like the Freescale MMCAU. We've used it with the microchip PIC32MZ on one of the projects we did as well. But all of the wolfcrypt hardware acceleration will be accessible when using wolfSSH. This is a little bit about the directory setup. So at the high level, you have wolfSSH there. Oops. And all of the header files are going to be in wolfSSH. This is going to be the header files that you would include in an application if you're using it as a library. Our example file, just examples in general, I guess, are going to be in the examples directory. This includes like an example server, example echo server, SFTP client, also like our port forwarding examples in there. Our source directory contains all of the sources. This is the SCP implementation, SFTP implementation, and just the SSH library itself. Our apps includes the production-ready applications. This is going to be like wolfSSHD and our wolfSSH client application. And IDE directory is going to contain easy access to ports that we've done. What I mean by this is like the MQ export, Expressive, Renaissance. It helps get you started quickly on specific IDEs for embedded devices. The one listed in there that's not embedded would be like the WinVS IDE. That's for the Windows Visual Studio build. So where would you go to download wolfSSH? Well, there's a couple of locations. One of them is at the wolfSSL website itself in the download section. The other one's up on GitHub. If you wanted to see more of like the bleeding edge of the code base, it would be up on the GitHub repository. I guess here I should also mention that it's dual licensed. So we have the GPL version of it up on GitHub. Anyone can download it and use it in a GPL project or do testing with it. And then if you were to get like a commercial license for a commercial product, you'd come to wolfSSL and we could could work that out for one of the commercial releases. Delving in a little bit more about the resource usage, I went ahead and collected a heap usage chart from connecting to wolfSSHD and opening a shell connection. And this is using Valgrind's Massif tool and then just a Massif visualizer. So you can see my configuration that I used for the wolfSSL and also for wolfSSH, both on the most recent versions. We configured wolfSSL with the SP small. That's to help a bit with reducing the size. It affects the performance a little bit, but it's still pretty performant even with SP small. And then I also set the default window size with wolfSSH down to 4096. So that's a tunable buffer for the window size after it's like first establishing a connection, how much memory it holds open for passing data back and forth. The default is quite a bit larger than 4096, but we made it configurable so that you can adjust it for performance versus size trade-off. 4096 would be closer to like a build for real resource constrained embedded device. And the heap peak heap usage was 35.4 kilobytes with wolfSSHD servicing a shell connection. So a little bit about building for wolfSSH. The first thing that you need is wolfSSL. It depends on the wolfcrypt portion of wolfSSL for all of its crypto operations. It can be gotten either from cloning the wolfSSL repository or also from that download site mentioned before. And this is for like Nix style or Unix style systems and using auto tools. You'd run autogen.sh if it was cloned from GitHub. If it's downloaded from the wolfSSL website, it would just be the last three steps here, which is configure, enable SSH, make, and then I make install. The enable SSH is going to get you the base build just for the wolfSSH library itself. When you start adding in additional stuff like the X509 certificate support, you need additional enable options. After building wolfSSL, then you can move on to building wolfSSH, which makes use of the wolfcrypt portion of wolfSSL. To build wolfSSH, you again need the autogen.sh command if cloning directly from GitHub. Then you could run configure, make, and make install. And that would get you a basic example client, basic example echo server, and the wolfSSH library itself. If wanting to see debug information after the library is, when building the library, you'd want to use the enable debug flag, or if you're on like a Windows Visual Studio build or something that's using not using auto tools, you'd want to define the macro debug underscore wolfSSH when compiling. It's set up very similar to how wolfSSL's debugging is in that after building it with debugging enabled, you still need to make a call in the application to wolfSSH underscore debugging underscore on to start up the debugging log output. And it can be turned off with wolfSSH debugging off. If not calling that wolfSSH underscore debugging underscore on, then no debug logs will be printed out. It also has a logging callback setting function. So this is if you want to have your logging messages piped to a different location, or to do touch up on the logging messages before they're printed out. you can set a customized logging callback function and do that processing in that logging callback function. By default, when we can, we have timestamps that are attached to our logging, and where we work with a lot of embedded devices, we understand that there might be some that don't have a good source of time available for logging. So we added this wolfSSH underscore no underscore timestamp macro, and that can be used if there's not a good source of time on the device. Some of the build options that are available are listed here. It's a very modular as far as how it can be built. We have the enable SFTP and SCP. There's also the port forwarding, which is enable FWD. All of these options can also be seen if you run /configure and space -h for the help menu. It'll show off all of the enable options available, along with short descriptions of those enable options. There's also the sudo terminal support with enable shell. Enable certs gets you the X509 certificate. One of the things that we did similar to wolfSSL is the enable small stack. There are certain devices that have or that want to use more heap than they want to use stack. So this enable small stack pushes more of the memory over to heap than on the stack. There's also the enable SSHD, which is used for building the wolfSSHD application. And if wanting to test or just wanting to have all options available and all features turned on, there's the enable all option. Another way to go about building wolfSSH is with our Yocto layer. So we have a meta recipe layer in our meta wolfSSL GitHub repository. It's under the recipes -wolfSSL. How you'd go about this is you'd add the meta wolfSSL to your bblayers.conf, and down here's an example of having done that. I had mine named meta-wolfSSL-fork, but it's the same type of concept. You just do meta wolfSSL, doing a clone of our wolfSSL meta wolfSSL repository, that is. And then I believe recently we've made it so that there's one line that you have to uncomment to enable the wolfSSH layer. That step's documented in the meta wolfSSL repository. And after having done that, then you can do bitbake wolfSSH, and it'll just build it into your Yocto build. When building on Windows, both wolfSSL and wolfSSH directories need to be at the same level for the default Visual Studio projects to work. This is a gotcha that one of the gotchas with the Windows Visual Studio build. The reason for that is our default Visual Studio solution in wolfSSH is set up for looking specifically at the same level directory for our wolfSSL directory, and then it goes into that directory to find the already compiled wolfSSL library. The next thing that you would do is copy over the user_settings.h from wolfSSH to wolfSSL. You'd want both libraries to be built with the same user_settings.h. This is to make sure that when the wolfSSH library is linking to wolfSSL, it has all of the same macros defined. So it's expecting the same, type, size of structures and the same feature set to be available that wolfSSL was compiled with. Then you build the wolfSSL project. There's a wolfSSL Visual Studio solution in the root directory of wolfSSL. So it'd be the wolfSSL 64.sln. Then the last thing that you do when building with Windows is build the wolfSSH Visual Studio solution, and that's located in wolfSSH IDE WinVS wolfSSH.sln. Another thing that people commonly do with wolfSSH is to cross-compile it for other devices. This is a pretty straightforward example of cross-compiling for the ARC64 environment, just a basic ARM environment. You use pretty much the same auto tools configure line that was used previously, but add this -- host option to it. And auto tools by default tries to get the compiler and linker and everything that it needs to get from this -- host option. In more advanced setups, you would have to set like the CC and LD and all of those individually. But for most of the simple cross-compiling steps, it's just adding this -- host and the beginning portion without -GCC or -LD for which system you're going to be targeting. So that's great for building the wolfSSH library, but how would you go about actually making an application use the wolfSSH library? And as mentioned, wolfSSH was initially created as an SSH library with a couple of applications recently added in the last couple of years. But to link to the wolfSSH library, you'd use -l wolfSSH on a Unix environment. They would look like the following GCC command for compiling a simple app that would link to wolfSSH. And in that application, you would include the header file wolfSSH /ssh.h. This pulls in the base SSH API that we have available. Things like our wolfSSH accept for on the server side and our wolfSSH connect _connect from the client side. If doing things like SFTP or SCP, we have a couple of separate headers that can be included for APIs to use the SFTP library or SFTP API, excuse me, or the SCP API. Some of the tests and examples we have, there's a unit test. It can be ran with make check. It's used to verify the API and some of the basic functionality. We also have an example echo server. A lot of support was thrown into that, like the SCP and SFTP support. It also has some of the basic shell support. And then we have our wolfSSH client example that establishes a basic connection to an SSH server. Port forwarding example. There's a SCP client and SFTP client example in the examples directory, and then SCP on the server side, and shell support also in the example server, as I mentioned before. Each of these examples has a -h option, which gives you a nice list of all of the arguments that can be passed into the example. And with our example echo server, one of the things that's nice listed here is the -j, which is our X509 PEM cert. And yeah, so it can specify for the public key to be used for the authentication. And with our example client, it's set up a little bit differently than the what you would standardly think of for a client, in that it has a -u for the username it's required, and it also has -p for the port and -h required for like the host that it's going to connect to. Our application that I'll talk a little bit more about later is set up more like a drop-in replacement for OpenSSHs. So it handles the user at host type of syntax. But also in this example client, I'd like to point out here that it has this -j again for use with X509 certificates. And you can use -A to for a CA certificate to verify the host with. So with our example SFTP client, it supports a lot of different standard SFTP commands. All of those commands are listed down here on the bottom, such as like cd, change mod, git, ls for listening the directory. In addition to that, it also has what we call like a one-shot kind of operation. So with this dash lowercase g and dash capital G, a lot of implementations are doing away with SCP. And when you type a SCP command, it actually does like a SFTP command that's equivalent to the SCP command. That's kind of what these dash lowercase g and dash capital G are, is replacements for a one-shot like SCP command. All right, so let's look at a simple client and server example in more detail with how they would connect together. Both can connect to each other. Also, there's interoperability where either can connect to an OpenSSH client or server. The examples have a couple of users hard baked into them, and those users being Jack and Jill. And the password fetch a pail for Jack and up the hill for Jill. So by default, they're going to know that they're not going to, the examples aren't going to go out to the system. So if you have a user registered on the system, in my case like Jack, it wouldn't be able to authenticate that. It's just a very simple authentication mechanism put into the example echo server and example client. And this would be a couple of examples of calling them. So this is a Unix, somewhat on a Unix style of system. So you have the example server started up, and then the server is not gonna open a shell connection. What the server will do is just respond back with hello wolfSSH after the SSH handshake has completed. And then this is the server started again with the OpenSSH client connecting to it. You can see that it establishes a connection, and then at this point we also had characters being echoed. So this is just echoing back each of the keystrokes. And an example of it handling public key authentication. So we have a couple of example keys in our keys directory, one of those being the Hansel key RSA.pem. So the example server has that hard-coded as being accepted. So if it for authentication, that is, so if it sees the Hansel key RSA.pem, it accepts that connection. And by default, it's going to be on, I don't think I mentioned this, but by default, all of our examples are on port 22222, so 5 twos. That's somewhat similar to our default port that we use with wolfSSL, which is 5 ones. We just use 5 twos. Next, getting on to the couple of applications that we have. We have the wolfSSHD application, which is a couple of years ago, and is SSH daemon. It can handle opening pseudo terminals, can handle SFTP connections and SCP connections. It's ported to a couple of different environments. It's used on both Linux and Windows. It can be ran as a Windows service. It's located in the app's wolfSSHD directory. If having built with wolfSSHD and having installed the library with the wolfSSHD application, it'll get installed automatically to the user local bin, or if you're adjusting the prefix wherever you set your prefix to when compiling, it'll install to the bin directory. And to be able to compile wolfSSH with it, it needs the enable-sshd flag passed in. There's a handy help menu that can be printed out with -h. It has the port number that can be overridden, debug mode with -d. We also implemented the ability to run it in the foreground. So with -D, which makes it nice when wanting to have more control over it or doing debugging. -h will get you private key file to use, and then -e for appending to a log file. So you can direct where it's going to print out its debug messages. And with -f, it has the configuration file. This is the equivalent of like the SSHD_config file. It's got it handles the same syntax as what OpenSSH does. wolfSSHD was meant to be an easy drop-in replacement for something that's already running a OpenSSHD application or daemon. And we handle quite a few options in that SSHD config file. Some of those being like whether or not password authentication is enabled, whether or not the user is allowed to log in. We also handle things like grace login period. Yeah, there's quite a list that we support with the SSHD_config. And the other application that we have is the client application to compile wolfSSH with the example client, or not example, the client application. Sorry, built is --enable-ssh client, and that's also located in that apps directory. Has a nice -h option for displaying the help, and it's set up to handle the same type of syntax as what OpenSSH's client does. It's also like wolfSSHD. It's meant to be a drop-in replacement for the OpenSSH client, so it can handle username at some host, and you can also specify a port and a few of the other options that the OpenSSH client also has. That goes over a high overview of getting started with wolfSSH, where to find it, a bit of what it is, building it, and some of the features that we have. At this point, I'll go ahead and open it up for questions that we have.
Yes, there is a question. SSH is a client-server communication only, or they can be server-to-server communication, like primary and a secondary server?
I'm not sure I completely understand the question, but it's, yeah, a server and a client connecting. So you have two endpoints, and you have one that's basically the client connecting over to the server, initiating the connection, and then an exchange of keys, and then the connection is established.
There's another question. For SCP and SFTP, it isn't necessary to have another IP port open, or everything is happening within established SSH connection. On the client side, it is enough to have just standard SSH client or combine SSH plus SCP plus STFP all in one client in mandatory.
Okay. So right now it is using the same established port for the SSH when it initially established the handshake for SSH. That's one of the things we've actually looked at potentially on the roadmap is making it so that there's multiple channels open. But yeah, right now it's on the same channel for SFTP and SCP.
There is another question. What is the difference between SSH server and a SSH agent?
Okay, so with the SSH agent, it's more of like based on my coworker did the implementation of the SSH agent, but it's based more on like the authentication, how it gets the authentication. So you have like in OpenSSH, you have the SSH add command that you can add keys to the SSH agent, and then you can go through that to get you can go through that to be like passing along your your key for authentication when you connect to a system, and then use that for authentication. Good example of that is like if you're logging into a remote system and you have the -A for passing along your key to then do SSH connections or farther SSH connections once you're logged into that remote system.
There's another question. Are SSH keys backed by FID or security keys supported as well?
Backed by FID. I'd have to get back to you on that one. And some of the keys that we do support is like we've added in OpenSSH style support. I don't think that's what this person's looking for with that question though. You'd have to contact us at like fax at wolfSSL for more detail on that.
And another question. Crypto algorithms are only used during handshake or later. During normal workflow, crypto can be used too.
During normal workflow, crypto can be used too. So like after the handshake is established? I'm not sure I understand that question. But yeah, when the handshake is first done with the SSH protocol, I mean it uses crypto operations for encrypting the handshake, and then it encrypts the data as it's passed back and forth after the handshake has been established. But yeah, if you contact us at fax at wolfSSL or support channel, we can get into more detail about the type of crypto algorithms that you can use, or if you want to use it at different locations.
We do have another question. SSH is limited to TCP/IP only.
No, we have IO callbacks, so you can plug in customizable IO callbacks. We've actually done SCP with no well, this was with no file system. What we've done SCP with no file system. And then we have the IO callbacks that can be used for the communication. And you can use examples of, you can plug in like York IO or basically anything that you'd like to with those IO callbacks. It's pretty agnostic towards that.
We have another question. wolfcrypt is included into wolfSSL 5.6.6 zip, or it is necessary to download both packages separately.
Yeah, it'd be necessary to download both packages separately. We treat them like two different products. Just wolfSSH has a dependency on wolfcrypt.
Do you provide your own SSH client libraries? like Python or Java or available third-party libraries should work?
Okay, so we provide the C implementation of our SSH client. We don't have a Java wrapper around the wolfSSH, and we also what we provide is just the C code itself. So not any like pre-built binaries.
There's another question. Can you describe SSH without shell support? What can be a use case for such variant?
Sure. So one of the use cases would be if you have and this is a use case that has been used with wolfSSH, is if you have a system out there that you just want to get like the debugging information from an application that's running, you wouldn't necessarily need to set up shell support for that. You could just have a SSH connection be established and have the information be piped along that channel. Another use case could be potentially be like a firmware update use case where you just want to pass a blob basically or a file firmware over to a system, and you want to establish a authenticated connection before doing that.
There's another question. How does wolfSSH server securely store its key?
Sure. So the daemon side of it, how we go about with the key is we at least for authentication is we reach out to the system and check the username against the usernames logged on the system. We also do the password the same way, relying on the environment that it's on. As far as key storage itself, if you're talking about just like like our example server dash key.pem, we would rely on the architecture of how it's used. So it's more like the how individual for how you set up your own project for managing the keys. So it doesn't do too much of managing the keys. It just makes use of it.
I have another question. I cannot start configure.ac. It seems some tools are not installed. What are prerequisites?
Okay. Some of the prerequisites is well, auto tools, auto recon, libtool is one of the other prerequisites. Then obviously a compiler on the system, but most of those. We can go into more detail on that on like a support case as well. Take you through step by step and see which issues you're running into. But it's the common like bin utils on an Ubuntu system. If you do like a sudo apt-get build essentials, it'll get you most of those tools, and then you know you'd also need the libtool and autoconf tools.
I have another question. Does wolfSSHD have chroot jail support?
Yep. The short answer is yep, we do. And we've done quite a bit of testing around that too. chroot jail both a shell connection and a SFTP connection. There's also support for specific users. So in our SSHD underscore config, when parsing of the SSHD underscore config file, you can specify specific users that you want to be jailed.
Perfect. If there is no more question, thank you, Jacob, for hosting an informative webinar and everyone for joining the webinar today. Please don't forget to follow us on Twitter at wolfSSL as well as the socials. Thank you again and see you next week.
Thanks, Shizuka. See you.
Okay, bye.